Recording is in progress. Good evening, y'all. This is Platoon. What are y'all, Foxtrot? That's right, Foxtrot. Week 5, day 2, module 1. We're still in class composition. Today we're going to be talking about inheritance a wee bit. This is going to dig a little bit deeper into what you worked on yesterday, and we're going to show how you can inherit no, really anything. Properties, methods, whatever you'd like from the parent object. We're going to do it with a really fun sounding game, but it's really basic and simple, and it's not going to be fun at all. But it's going to itch that node for anybody who thinks they want to build a video game. I promise you, you probably don't. You've been hired by a video game developer to help them create the latest medieval fighting game. They have some code from a previous game with classes for knights, offense, and defense, but they want you to expand on it. We're going to put weapons into it. Sounds fun. It's real basic. So let's look at what they've got, their current code. Let's read through this real quick. Make sure my phone's on silent so I'll make a bunch of noise during all this. Right off the bat, we're importing random to do something that I had to brush up on last cohort, and I had to refresh myself this cohort because this is crazy looking. So we've got a class called offensive system. You instantiate it with a weapon, self-weapon, and it does one thing. It's got a method called make attack, and it just prints attacking with weapon. Real simple, nothing crazy there. Defensive system. This is where we're going to get into some stuff you may or may not have seen before. The defensive system uses static methods. These, if you don't know what a static method is, it's basically a method that can be called without really instantiating or referencing the instance of defensive system here, or whatever class. These, notice, the standard method is going to use self because it is referring to itself, and it has to because it needs to know self.weapon. So it's since it's using instances, properties from itself that are instantiated from it, it needs to reference that. This is showing us, hey, you don't really need to have an instantiated defense system. I just want to be able to reference it and call things from it. It's almost like setting up your own library in a way. This is just going to be an object that we can reference methods from that we don't necessarily have to instantiate. The way it's used here, and again, I think this is the main point of this is just showing you, hey, these are things. Look them up if you want to know more about them. But in general, a static method does not refer to the instance of the object. It is a static, i.e., shoot, what's the word? Anonymous function, kinda. It's just it's not quite correct, but it's basically just a method you can call from this object without having an instance of the object necessarily refer to the method. We can dig into that if y'all really want to know, but you'll probably get more out of reading it than I can explain it, because that's how I explain it to myself. I don't use these very often. What we've got here is this method, engage defense. It takes probability, does choices, true or false, weights them, and then gives us the first one back. What the heck is that, Jordan? Well, choices is coming from random, and if we want to look at it, this doesn't help, by the way, because that's doing a lot more, parameters and values of what we're doing. I'm going to walk you through what it's doing. And I also think it's kind of silly because we could probably make this a lot less complicated and also in one line. Choices, first argument, are going to be the choices, which are true or false. What is the weights? So this isn't just going to pick one or the other. It's going to pick them with a weight offered, basically. So we want true to happen more often than false. You can probably very quickly figure out how you'd probably do that on your own. Using the choices library, though, this is pretty concise. True is going to be equal to probability. False is going to be equal to 1 minus the probability. So most likely probability is less than 1, i.e. a percentage. So if we were to offer it like, I don't know, 0.7, the weight of this one would be 0.7. The weight of this one would be 0.3. So 7 times out of 10, you're going to land on this one. 3 times out of 10, you're going to land on this one. What's the zero? It returns a list. Choices can return a it can just keep running through this this list here. If I said, hey, true or false, but I want, I want to get I want a list of like 15 times. I want to see how many times it comes out. You could do that, but it still does return a list. So this zero is saying, hey, the first place, there's only going to be one, but it still returns a list. This is just basically going to give us true or false. So it's going to give back a list with one thing in it, true or false. We're going to take whatever it is. So all this to say, this is going to take a probability, return true or false. Then, since it's a Boolean, not, well, it's truthy falsy, whatever. If it's true, run this function, block. If it's false, run this one, dodge. All this does is tell us whether or not we're going to block or dodge. I don't want to get too caught up on this. I already have, but I didn't want to just glaze over this because I remember last class, I think I kind of blasted through it and everyone's like, wait, what the heck is that doing? And even though I knew what it was doing, I couldn't explain it well without really digging into it. So that'll be good for now. If anyone really wants to go over it more, we will. Lastly, we got a class. This is night. This is all this is going to be doing is taking using class composition, referring to offensive system and defensive system. So this night object, which is the only thing we'll be instantiating, we'll be able to access all this, both of these other two classes. When it makes an attack, it calls on the offense, make attack. Looks good. When it calls defend, calls on the defensive system and engages defense and runs through all that code. Let's test it out. Ooh, no cheating. No, that's not what I want to do. That's another thing. Oh shoot, Chad put this out. What do I want to do? How do I want to do this? This is what I get for doing things on the fly. No, I'm not gonna mess with it. Chad will mess with it. I want to show you a Git workflow because it seems like y'all are struggling with it a little bit, but I should probably. I'll do that next class. I just read this as I was jumping in. I was like, oh, I can do that. I'm not gonna do that. All right. Not there. Lecture.py. Don't tell I haven't been in front of the computer all day. There we go. So copy pasted everything we've talked about. This file is going to instantiate a night, run an attack, run defend. Let's see what happens. Let's see if this is all pasted as we expect. Cool. And that worked out great. There was only a 30% chance, 30% times 2, 60% chance we were going to get the 2 that we wanted. I think that's how percentages work. Anyways, knight attacked, attacking with sword, looks great. Relied on the offensive system class. Defensive, we call it twice to hopefully get one blocking and one dodging. If we run this a few times, we might get, see there, that's one here. They both ended up being blocked. That is the more likely. Yeah. More likely to block than dodge. Any questions about that? I didn't want to blow through it too fast, so we're all on the same page as we add more to this, but also it's kind of simple, so it's okay if you don't have questions. So remember, they want to add weapons. Let's add some ranged and melee weapon classes. The developers want you to add weapon classes to have weapon names and attack functions. Let's copy paste it and then take a look at it. So melee offense looks easy enough. We instantiate it with a weapon, and then we make an attack, and we print attacking from self, weapon here. From really close, this is a melee attack. It's within melee range. You're hitting each other with a sword. Ranged offense, same thing. We instantiate with a weapon. Here it is, and we make an attack. You didn't even see my weapon coming. I don't know if this is some kind of video game reference or something. I think it's just showing that it's a ranged attack. I don't know. If y'all do, tell me. I'm video game references are rarely missed on me, but I don't know what this. I think this is just silly. I would have, I don't know, done something like, well, whatever. Cool. Who sees something they don't like about this? Somebody has to, because I'm not moving on until someone tells me what's wrong with 38 through 51.
The two make attack functions is.
Say that again?
The two make attack functions,
What about them?
they're the same. They're titled the same.
Oh, they're titled the same, but they're doing different things. But you're on to something. You are right. You're going the right way. In short, we're duplicating a lot of work here, right? Melee offense needs to have a weapon instantiated. So this is ranged offense. It's got variables for both. They both have a make attack function, so that is duplicated. They do different things, but if we were JavaScript developers, we'd be blowing our what's the word? Our gaskets. There's too much replicated lines. You can't have that. All pretty much what 2, 3, 4, 5, 6, 7, something 7 lines or whatever are doing no useful work. And don't forget, those look a lot like this, don't they? We already have an offensive system that really just takes a weapon. Surely we can leverage that class into this, so we don't have any duplicated work. These classes need to be doing specific different jobs, right? If they are starting to do similar work, if they're doing things the same way, that's an issue. That's redundant. Redundancy is not just, a bad thing because it wastes lines, as we've mentioned. If I need to go fix something and say, hey, oh, by the way, video game developer, I don't want this to say, I don't want it anonymously attacking. I want it saying like, the player is attacking with, or on all these. You'd have to go through and update this and probably this, because the knight uses that. That's 3 different places we're now making updates to the same exact output. That's a pain. That's not growing well, right? That's not scalable. And you're going to miss stuff. You're going to have, kind of things left out. So let's trim it down. And we're going to be using inheritance for that. I just said all that with way more words. This is an example of inheritance. It's not directly related to what we're doing right now, but I'm still going to kind of pull it out and show you and work with it, because thinking about knights and weapons and stuff like that is all fine and dandy, but it's a lot easier to think about inheritance from a parent and child standpoint. Here's a class of parent. Here's a class of child. Parent seems fairly simple. Instantiate it with this variable called properties, and then it's got a method that prints. This is method 1. Now, child, look at this. We plugged parent into child, and then using this little bit here, we are inheriting the super class, basically. Child is inheriting parent. You refer to super as whatever it's coming from. And we ought to and will be able to reference anything from parent within this child class. That only goes one way. Child knows about parent. It knows about the parent's, properties, values, whatever, methods. It can reference all that. Parent cannot. Parent doesn't know about any children it has. It's not a good parent. That the kids are running around doing whatever they want. Parent only knows about their self. It's like a bowling mom, not a soccer mom. It's a bowling mom, and I'll prove it to you. Let's run this. All right, cool. Does not put anything. So we've instantiated P1 parent, and then we're going to call method 1 and invoke it. So this is method 1. That's what we expect. We called this parent. It has method 1. Now, child, at this point, ought to have method 1 as well. See there? They've called method 1. So the child can use this method, but they've also got their own method. This is child method 1. Should be probably named something different. Don't ask me why it's in Pascal case. That's not Pascal case, is it? Camel case. This is child method 1. So it can reference method 1. It can reference child method 1. It can reference its own properties. So child properties. I guess you'd have to print that if you wanted to. I am a child. It also should have parent properties, and we can prove that. Oops. Property, I'm a child, property 2. Well, so what we've done here actually is its parent properties we've overwritten. Child takes in parent properties and new properties. We have blown away parent properties when we created property 2 here. So you can overwrite properties from a parent, or you can inherit them down if you'd like. We don't have to blow them away. We're just showing that that's what would happen. Wait, did I do that right? Does that make sense? Hmm. Hang on now. That's not what I expect to see. Oh, yeah, okay, no, because we're instantiating with the parent properties that are passed in, we are overriding it. If we didn't want to do that, let's back up on that. Hold on, let me pause real quick. That's not doing what I expected to do at all. We resumed the recording. Sorry about that, y'all. I got my wires crossed. We have to provide some parent properties. They are going to overwrite the parent's previous properties, because we haven't established a parent yet. Since we need to create a parent while we create the child when we're instantiating it, we're going to be feeding it parameters so that we can meet this. Think should be able to just pass in parent, or a previously created parent if you wanted to. I don't know. That'll get into composition. We have displayed that you can reference the parent's methods and values, properties from the child. Doesn't go the other way around. Parents don't know about the kids. Kids know about the parents. That's how inheritance works. Let's get that off this page so we can get back to this. Okay. Using this framework, the child class inherits all instance properties of parent, thanks to this, but also inherits all of its methods. Parent inherits nothing from child, like we said, thus running C1.parent properties would output property 2, and C1.method would output this method. Yep, that's what we saw. Works like intended. So applying inheritance simplifier game code, we now have the following weapon classes. We have melee offense, which is going to be taking offensive system, and then ranged offense, which is also going to be taking offensive system. We are going to be instantiating it and referencing offensive weapon in both of these. From there, let's go to the full code and walk through it. Cool. All right. So offensive system has not changed. It's doing the same thing it was before. We haven't changed that at all. But now melee offense is going to reference its parent and then print its own thing. Remember earlier, what we wanted to do was print 2 lines of code. Once was pretty much what offensive system provided, and then from really close. We're doing that now. Oh. Yep. We're doing that now, but we're not duplicating any unnecessary code. Ranged offense is actually not referencing the method from offensive system. I don't think it's really doing anything. That's about it. It is just going to print out its own response. It's not leaning into the offensive system. That's it. Doesn't really need to inherit anything because it's not doing anything with offensive system. But we could, building upon this, we definitely could. Defensive system has not changed. Knight has not changed. Oh, wait, technically it has. Yep. I think we're using melee offense as this sword here. We could use ranged offense instead, but now we're specifying, hey, we want this to do melee offense things because it's a sword. Let's run it. Yep, looks good. Notice we were attacking from really close. If this knight were to, I don't know, drop his sword and need to pull the longbow off of his back in the middle of the fight, because that's how that works, he would be able to do that too. And that's working as intended. Any questions? I don't know, ranged offense is kind of not really leaning into inheritance, but melee offense is. Any questions about how that works? We talked about test-driven development. We talked about tests. I'm going to talk a little bit more about tests. So we have this other file here, lecture, but with tests. We're going to go in there. And I've set this up like I did with the last lecture. Again, set your projects up any way you want, but be consistent is what I would say. I don't love a bunch of different classes on one file. One, it gets to be a lot. It's hard to read. Nobody wants to see, 700 lines of code ever in their life. The only time it should ever get that big is if its configuration, and really, I don't want to see it that large ever. It should be broken down. That's too many errors. potentially on one line. That's hard to track down. And more topically, I find that very difficult to test. Hitting the same file from a bunch of different, with one big file, you're going to have an equally large test, right? What I would like to see, in fact, I'll open up the trees because that's how we're going to look at it. I would rather break this up into defense.py, night.py, and offense.py. And even these can be broken down more, but we won't get too into that. Real easy. You don't even, the only ones that have to reach out and import the others is night, because defense and offense are kind of agnostic to anything else going on. So night will import them. Notice we're doing models.offense because even though night is at the same level of them, most likely we're going to be invoking from above. And we're definitely going to be invoking from above at this level when we're running our tests. So nice, clean, easy. Our unit tests are going to be exactly the same. They're going to be carbon copies for defense.py, defense spec, night spec, offense spec. It is a lot easier, and that is subjective, but I'm going to say it anyways. It is a lot easier to test small file on small file, small file on small file than it is to run a bunch of tests on a bunch of different things, or have a lot of different tests referencing one file. If you have an error on one file, you really only want it to kill, you're shrinking the blast radius of that failed test, right? If there's a bug that causes nothing to be able to run from a file, you should be able to, your other tests should be isolated from that, and they'll still run. Actually, shoot, I'm saying it, let me show you. Run test file, like I've shown you before, it's literally just this. I just like it. Do these run? Oh, I didn't quite get this bit figured out, but my test fails on this defense bit. I just need to look it up, but I wasn't quite sure the best way to test to get both of these back. I'm pretty sure I can say the cert equals is within this range. I just forget unit tests. I was writing this up about 2 minutes before class started. I was running out of time because I wanted to do it. So if we had an issue, like what if we forgot to import these in night.py? We run our tests again. Notice we still passed 3 of our tests we set up. All of the defense spec and offense spec ran without a problem, no issues. The only one that failed was this night spec, and it was a pretty easy test also. It was literally just what I'd call a smoke test. I don't have anything great to test, so I just want to set up an instance of night and then run a test. But we failed that. Notice melee offense is not defined. But we didn't just blow up and not get anything accomplished. And we're not sitting here with a traceback for all of our tests. We isolated, what we wanted to test and had tests specifically for them. And an issue on one is not going to kill the entire testing suite. So real easy for me to go back and find the one failing thing. Oh, melee offense is not defined. That is on line 6 of lecture book with test models, not pi. Easy peasy. Got it. Great. Run tests. Looks good. Does that make sense? Does anyone have any questions about how I've got this set up? Does anyone think unit tests are dumb? You can think that. There's actually a really interesting, like kind of back and forth of these 2 YouTubers. I'll post them to the Slack channel. One of them works for Netflix. The other one works for Twitch. And the one who works at Netflix is all about tests. He's got unit tests for everything. He wants all the unit tests. He wants them written very well, and he's very confident about the way he writes unit tests and the value he sees in them. And the one who works for Twitch. And by the way, these aren't just like, yeah, I work there. These are like team leaders. So there's a team leader at Twitch, which is paid pretty well. He's really high up there in, their their organization. This is somebody who's got a bunch of people under him, a bunch of developers working at a high level. These are really smart people, and he says, yeah, tests are dumb. I don't like them. I would rather have 100 other, different ways to go about it. So just because I'm pushing tests, Code Platoon's pushing tests, what have you, it is really kind of going to end up, I don't know, where you're working. If you're required to have tests, you're going to have tests. But I think a good takeaway, if you're working on your own personal projects, is if you feel like you need tests, write them. And that sounds stupid, but really what it comes down to is if you find yourself fixing stuff often when you try to make changes, maybe unit tests would be able to help speed that process along a little bit. If you're constantly fighting changes, like application breaking changes, whenever you're trying to do very simple things, tests can potentially help you isolate those a lot faster, run prior to a commit. You can have pre-commit tests running. That way you don't commit bad code.
Quick comment on that. Do you think that has to do with the risk of like the risk that they're facing? So I feel like Twitch probably has pretty low risk when it comes to if their code goes wrong. It's not like it's like that detrimental, or it might be more detrimental for Netflix if something goes wrong for like there's a bigger market for like other streaming services and stuff like that. I don't know.
No, I like where you're going with that, but no, a production outage at Netflix, at T-Mobile, at like grandma's cookie shop, none of that is acceptable ever. If you have a prod outage, that is a serious issue. In all these cases, there very likely is a test environment and a development and then test and then production environment, right? So they're never pushing up broken stuff to production. More likely it is reducing, rather, it's a matter of the feedback loop is how long will we know that we pushed bad code after we push bad code? You know, rather, how long after a push, after everything builds up, after all, the whole product is redeployed, how long does it take to find an error, and how will we know if there's an error? How complicated is your code base is another thing. If you're doing really complex algorithms, a quick, look-see at a deployed site might be good for some sites. It might be, not good. There are plenty of other tests besides, unit tests, which are testing everything at a base level, such as like code coverage tests is a whole nother thing. Verifying that when you run a task, a liveness probe, or an end-to-end test, you're verifying that every single line of your code has been hit. So there's a lot of different ways to verify that your code is good, besides just what I would consider unit tests. And the way I would describe unit tests is like basically hitting every single method. Every method should have tests written for it. Edge cases should have, tests written for it. There's value in both. I think the bigger argument out there in the industry is maybe test-driven development is not such a good way to go about things. Again, it's up to you. It's how you want to do it. But there's a good argument for, hey, usually when you build something, you build it, you learn a bunch from it, you throw it away, and you build a new one. So having tests pushing the development of a product can be difficult if you're not really sure where that product's going to end up. And if you're going to be learning lessons along the way, laying a bunch of infrastructure along an alpha build is not such a good idea. And if you already have lessons learned from your first attempt to build, maybe you don't necessarily test for that. It gets very like nuanced as far as like what your product is. Generally, when you're doing a lot of algorithmic stuff, a lot of math, a lot of crazy manipulations of data, unit tests tend to be very useful to have. If an end-to-end test would pretty much fix everything, and that's all that really matters, right? Like, I don't care if I've got this teeny tiny little bug that might, have some weird thing, as long as 99.9% of the interactions are this process, and you can walk through that process fine, yeah, we're good. I don't know. There's a lot of conversation on it. But I wouldn't. I don't know. The bigger the company, big companies just have really weird work processes, I guess. And you'll someday get to see all that. Man, I'm rambling and ranting. Any questions about this lecture, y'all? Your challenge for today, one of my favorites, ice cream and freezers. I find this to be a legitimately interesting assignment to do because I like to see how people walk through it. You'll be using inheritance and composition because you'll have something like, I don't know, a freezer and ice cream, and you need to put things in there, and you need to have methods that are associated with a freezer and an ice cream. I think getting here, you can start doing things like different flavors of ice cream, stuff like that. It's a fun one to work on. I think there's basically no tests set up, so write your own if you'd like. I've got a good example of one of these I did myself if anyone wants any help with it, but that's it. I'm going to stop this recording.